a remote monitoring tool to help authorities manage public safety and environmental issues in recently abandoned coal mines, has been developed by the University of Nottingham. The tool uses satellite radar imagery to capture millimetre-scale measurements of changes in terrain height. Such measurements can be used to monitor and forecast groundwater levels and changes in geological conditions deep below the Earth's surface in former mining areas. With a long history of coal mining, the project was tested in the UK at a regional scale, but has global implications given the worldwide decline in the demand for coal in favour of more sustainable energy sources. The method was implemented over the Nottinghamshire coalfields, which were abandoned as recently as 2015, when the last deep mine, Thoresby Colliery, shut its doors for good. When deep mines are closed, the groundwater that was previously pumped to the surface to make mining safe, is allowed to rise again until it is restored to its natural level in a process called rebound. The rebound of groundwater through former mine workings needs careful monitoring. Often containing contaminants, it can pollute waterways and drinking water supplies, lead to localized flooding, renew mining subsidence, land uplift, and reactivate geological faults if it rises too fast. Such issues can cause costly and hazardous problems that need to be addressed prior to the land being repurposed. The Coal Authority therefore needs detailed information on the rebound rate across the vast mine systems it manages, so it knows exactly where to relax or increase pumping to control groundwater levels. Measuring the rate and location of mine water rebound is therefore vital to effectively manage the environmental and safety risks in former coalfields, but difficult to achieve. Groundwater can flow in unanticipated directions via cavities within and between neighboring collieries and discharge at the surface in areas not thought to be at risk. In the past, predicting where mine water will flow was heavily reliant on mine plans, inaccurate or incomplete documents that are sometimes more than a century old, and borehole data. Costing approximately £20,000 to £350,000 each, boreholes are expensive to drill and are often sparsely situated across vast coalfields, leaving measurement gaps. More recently, uplift, subsidence and other geological motion has been monitored by applying interferometric synthetic aperture radar (INSA) to images acquired from radar satellites. However, this interferometry technique has historically worked only in urban areas, as opposed to rural ones, where the radar can pick up stable objects, such as buildings or rail tracks, on the ground to reflect back regularly to the satellite. This study uses an advanced INSA technique, called Intermittent Small Baseline Subset (ISBAS), developed by the University of Nottingham and its spin-out company TerraMotion Limited. INSA uses stacks of satellite images of the same location taken every few days or weeks, which makes it possible to p. Uniquely, ISBAS INSA can compute land deformation measurements over both urban and rural terrain. This is beneficial when mapping former mining areas, which are often located in rural areas. Over the Nottinghamshire coalfields, for example, the land cover is predominantly rural, with nearly 80% comprising agricultural land, pastures and semi-natural areas. Such a density of measurements meant study lead, University of Nottingham PhD student David G. could develop a cost-effective and simple method to model groundwater rebound from the surface movement changes. The study found a definitive link between ground motion measurements and rising mine water levels. Often land subsidence or uplift occurs as a result of changes in groundwater, where the strata acts a little like a sponge, expanding when filling with fluid and contracting when drained. With near-complete spatial coverage of the INSA data, he could fill in the measurement gaps between boreholes to map the change in mine water levels across the whole coalfield. The model takes into account both geology and depth of groundwater to determine the true rate of rebound and help identify where problems associated with rebound may occur. The findings have been published in a paper modeling groundwater rebound in recently abandoned coalfields using D and SAR in the journal Remote Sensing of Environment. David G., who is based in the Nottingham Geospatial Institute at the university, said, "There are several coalfields currently undergoing mine water rebound in the UK, where surface uplift has been measured using INSA." Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.